So now in this video I have the LM358 op amp here wired as an integrator. So what it's going to do is when we give a voltage change, right now the input is 12 volts, it's off the chart there. We're going to drop it down to 0 volts, and it's an inverting integrator. And there you can see that when we got to 0 volts, the voltage started going up. That was the output. The red LED you could see was lighting up. Now we're going to do the opposite. We are going to go from 0 volts up to 12 volts, so you can't see the top up there, but you're going to see that we have a voltage ramping down, and I set the timing so that you could see the LED changing in real time, even though that's kind of a steep ramp. One thing I'm going to do now, so we were using 12 volts just to get the LED nice and bright. I'm going to drop the supply voltage now to 7 volts, so we have the input to the positive supply. It's a little lower than 7 there for some reason. I probably got to adjust the lines. But in any case, we are going to look at the voltage we can get from the output. There we jump it up. We'll see that it falls at least a volt short if there's no load. And then with the load, looks like it's falling a little more. If I pop the LED, you can see it goes up a little bit more. So that's something to be aware of when you're using the LM358. It's a single supply op amp. Can go to the negative supply, but not all the way up to the positive supply, which I will show out again right there. 7 volts at this time. So now we'll look at the schematic diagram. So to begin with, we set half of the supply voltage. We got plus 12 volts and 0 volts there. So 6 volts there. Usually when you see this circuit though, the integrator, you'll probably see a positive voltage and a negative voltage in relationship to ground, and they'll just put ground right there. So that's just something to be aware of. Now we have the capacitor here. So our voltage coming in is changing, going up or down, and we have a capacitor there. So it's going to charge and discharge, and the output is going to be a big factor in that. So it's going to change. It's going to go higher or lower as needed to keep the voltage at the inverting input, the same as the non-inverting input. So that's why you get a steady voltage change. It's trying to keep that voltage the same while the capacitor is slowly changing. So I really don't have a much better way to explain that. But in any case, as the voltage goes up, this should actually be flipped the other way around to match that. If you remember, when we had a lower voltage, the voltage rose, and when we had a higher voltage, the voltage dropped down. So I'll fix that before I post the diagram. But in any case, as the voltage goes up, then there's more voltage across the LED, and it gets brighter. So the output is going to provide the current needed to do both things within the limits of the component. And then when it goes down, voltage goes down, the LED is going to get dimmer, and the capacitor is going to be charging the other way. And here is the integrated circuit on the board. So we got to power it, positive supply there, negative supply there. We got the output top pin there for lighting the LED, which you'll see will get brighter when I put the jumper to the negative supply. So we got a about half of a microfarad capacitor there at the output, and then down one more to the inverting input where you can see the 4.7 million ohm resistor where we jump the jumper back and forth. And as I said before, our non-inverting input there, we just got half of the supply voltage right there, so that it shifts both above and below that half of the supply voltage. But in any case, that's it. I hope you enjoyed.